Good morning, grade 8s. Today is Friday, May the 29th, and today is the final day of our enumeration review. Today we're going to be looking at integers. So we'll just dive right in and get started. Okay, so first off, we have to remember to think about the number line so that we have in our mind where numbers are placed in terms of what's bigger and what's smaller. So if I'm having a negative number, my negative number is big, it's very deep in the negative territory, following that number line to the left there. Thinking about the number line will be helpful for lots of the things that we're doing with integers. So use of brackets. So here's an example of an addition problem that has brackets here. And this bracket is meant to show you that this is a -4. And they'll put that bracket there when it's beside an addition sign, or even if it's beside a subtraction sign. They don't put a sign here beside the 9, and when they don't put a sign, you have to assume that number is positive. Okay, so this is really positive 9 plus -4. When we take a look at this one here, we don't have any brackets because the -6 is the first thing in the sentence of math here. And because it's the first thing in the sentence, there's no other, there's nothing else it could be. You can't confuse this with a subtraction. It's definitely a negative here. And then we have the addition sign. This 11 is going to be a positive 11. Okay, so when you're looking at the work, you need to be able to kind of look at the use of brackets, where they're using it, where they're not using it, and you need to be able to determine whether you're looking at a negative integer or whether you're looking at a subtraction sign. And that can be tricky sometimes to decide which of those things that you're looking at. Okay, so the next bit of things is going to be adding and subtracting. So here I have an adding problem. We did quite a bit of this, if you recall, in class with those integer tiles, the red and the blue integer tiles. And I would say, okay, we're having our zero chain. And then we've got our 10 here that are, they're positive and they're red, and then we've got to add the 15 negatives. So we put the 15 blue in with the 10 positives, and then we're going to remove our 0 pairs. And when we do that, we end up with -5 as our final answer, right? Because we're going to match up our 10 reds with our 10 of the 15 blues, and they make a 0 pair that's worth nothing. And I'm left with 5 blues. So if you can imagine that, that's how the adding works. Subtracting is a little bit difficult, more difficult. When we're thinking about it like this, here they have no brackets at all, but we need to, again, look at what is this question actually telling us here. We have a -2, a subtraction sign, and then this is going to be a +5. They don't draw the plus sign beside the 5, they expect you to understand that 5 is positive. Because there's only one sign in between here, this is a subtraction sign. So if I've got 2 blue and I need to take away 5 red, I need to use that 0 chain. So I've got my 0 chain. It can be as long as it needs to be. All my blues and my reds all lined up together. And I've got 2 little blues sticking out there because I've got 2 -2s. Then I got to take away 5 reds. So when I do that, when I remove 5 reds from my 0 chain, I'm actually going to end up with -7. I've got more blues without a red partner because I've removed the red partners. But a lot of people find this really, really confusing, and so there's a bit of a rule of thumb, and that's the add the opposite rule. So if I take this question here, -2 subtract +5, I can make it an add the opposite. So it's actually going to be -2. I take my subtraction and I turn that into an addition. And then I have to do the opposite of +5. So this is +5 here, but to make the opposite of that, I'm going to make it -5. And when I do this, I've got -2 and I'm adding together another -5. I put those together. Well, I'm going to have 7 negatives there. Okay, so it's the same answer, but using the add the opposite rule, we can keep our brains a little more straightforward in our minds there of how we're doing this. Okay, the next bit is multiplication and division. So whenever we're doing multiplying and dividing, we just do it the same way we normally would, but we have to follow this chart. So if you have two things that are positive and you're multiplying or dividing them, your outcome will be positive. If you have a positive and a negative that you're multiplying with each other or dividing with each other, your outcome is going to be negative. And it doesn't matter the order of that. If you've got mixed signage, your answer is going to be negative. If you have two negatives that you're multiplying or dividing together, your answer is going to be positive. Okay, so that's really important there. Let's just do a quick example. So if I've got -2 multiplied by -10, this is multiplication. So I know I'm going to have 20 because 2 times 10 is 20. And then I look at my chart and I go, and that's a negative, that's a negative. Oh, it's going to be a positive 20. Okay, and that works for the division exactly the same way. If I have a mixed one, let's say I've got -4 multiplied by 3. Ooh, I didn't draw the sign. What is it? It's positive. If you don't draw the sign, it's positive. So here I've got a negative and a positive. I know 4 times 3, that's 12. I know that. But is it going to be positive 3 or -3? Well, I look at my chart. I got a negative. I got a positive. That means my answer is negative there. Okay? So whenever you're doing the multiplying and dividing, we have to remember that chart. So committing that chart to memory is a very, very good idea. All right, exponents. So we know that with exponents, we are just doing repeated multiplication. There's another little rule here. If you have an even exponent, that means regardless of your base, let's say your base is 3, it doesn't matter, but you have the exponent 4 here, that's a positive, that's an even exponent. So 2, 4, 6, 8, 10, 12, 14, 16, 18, these are all even exponents. The answer is going to be a positive. Okay? For odd exponents, again, the base doesn't matter. It can be a 3 here. It can be whatever you want it to be. If it's to the exponent 3, well, 3 is negative, is an odd. Okay? And because 3 is odd, the answer will be negative. So, and like 1, 3, 5, 7, 9, these are all odd numbers, right? So if your exponent is odd, then your answer will be negative. Okay? All right, and I think that is the completed lesson. Remembering, of course, that 3 to the exponent 4 is actually going to be 3 times 3 times 3 times 3. Okay? Oh, we should make that. It doesn't matter if it's negative or positive. This is going to be, sorry, I guess it would matter. If this is a negative exponent to the exponent 4, my answer is still positive. Okay, this is a negative exponent here, but I've only got 3 of them, right? 3 is going to be -3 times -3 times -3. 3 times, my answer is negative. Okay? So yeah, it has to be a negative exponent for this rule to take place. Okay, so if the base is negative, you look at that even or odd. Okay? All right, so that is everything. Today is Friday. That means you get the weekend off. Have a great weekend. Okay, everyone? I hope you will all tune in again next week for our next round of review. I'm thinking it'll probably be geometry. Okay, take care, everyone. Bye-bye.